Section 8.5 is about hyperbolas. This is the final conic section that we will look at. Before we look at the function and see what it looks like, I want to first look at the two equations. These are the two equations that we have. They should look familiar. They should look like the ellipse equations, except with one major difference. The major difference is the subtraction sign. In order for it to be a hyperbola, it has to be a subtraction sign. Now, the first one is an example of a horizontal, and the reason it's an example of the horizontal is because the x term comes first. The second one is an example of a vertical because the y squared term comes first. Now, if you notice, both of them are written over a squared. A squared is always the first denominator in a hyperbola. Always. Stating this, A does not have to be bigger than B in hyperbolas. So it's a little bit different than ellipses in this manner. All right, how we get hyperbolas, if we take our two cones in this picture, and if we slice it so that it goes through the both bases, so if we slice it kind of perpendicular to both of the bases, I kind of have a parabola in there and then a parabola down here, all right? And this is what a hyperbola looks like. It's basically two parabolas kind of put together, all right? So a hyperbola is kind of a hybrid between an ellipse because it has a lot of the same characteristics, but also a parabola because it visually looks more like a parabola. So we're going to see some characteristics that are the same in both. All right, first, just like ellipses, hyperbolas have two axes. The first one is the transverse axis. This is basically the same thing as the major axis, okay, with respect to the ellipses. And the conjugate axis is basically going to be the same thing as our minor axis, all right? Now, we already talked about how hyperbolas are horizontal and vertical. Now, the horizontal one was because x squared came first, and that was over the a squared, and then there was some other stuff after it. And the vertical was because y squared came first, and then there was some other stuff that came after it. Okay? So, visually, here's what's going to happen. Is a horizontal hyperbola is going to open toward the positive and the negative x values. Okay. A vertical will open toward the positive and negative y values. All right. So in both cases, I have different transverse and conjugate axes. So I will label them now. Now, with respect to the horizontal hyperbola, our transverse axis is the x-axis. Our conjugate axis is going to be along something with the y-axis. Our vertical, our conjugate is now going to be something with respect to the x-axis, and our transverse is going to be something parallel to the y-axis. All right, what we're going to do now is kind of break this apart and kind of break it down a little bit to get some more details. First, between two sets of hyperbolas, I'm going to have a center. Okay. Now, I'll talk more about those terms in a second, but the center is midway between your vertices and the foci. Okay, so it's the same terms that we had with respect to parabolas. Now, just like with parabolas, I have two vertexes. And that's almost at the base of my parabolas, or in this case, farthest left and farthest right. Okay. Now I also have two foci, and just like with parabolas, they kind of go inside the parabola in a sense. All right, so I have the center, I have two vertexes, and I have two foci. So now I want to identify what my A, B, and C values are. A is going to be the distance between the red and the green dot. It's basically going to be the distance between the center and your vertex. Okay. C is a little bit easier to see, so we're going to do that one next. C is actually the distance between your center and your foci, that purple dot. All right. Now, with respect to B, I don't want to get too in detailed with these hyperbolas, but what B is B is this distance from the center up to this box. Again, I don't want to talk about where this box really comes from. I just want you to realize that B, along with the foci, so B and the foci, they're basically helping us determine the width of the parabolas. Okay, so what I can do a lot is I'll be given maybe A and C, and then I have to find B because B I need in the equation, but it's not as visually represented in this graph. The relationship between A, B, and C is the Pythagorean theorem. So A squared plus B squared equals C squared. Now, for hyperbolas centered at the origin, these are the formulas. Now, the standard form, the foci, the vertices, and the asymptotes will change when it's not centered at the origin. This chart is given to you on your cheat sheet. All right, so let's kind of start solving. Write the equation for the hyperbola shown. Well, first, since they give us two vertexes and two foci, I want to make sure I find the center. Now, the center is going to be midway between my two vertices, so basically I need to just make sure I do midpoint formula. I do not want to assume, I do not want to count, I do not want to assume. I want to show using algebra that my center is truly at 0, 0. Since I now know that point and I know the vertex point, that means that my A is going to be 3. From the center to the vertex is 3 units. My C is going to be 4. From the center up to the foci is 4 units. So that would mean then that C squared equals A squared plus B squared. So that would mean B squared is equal to 7. This is a vertical hyperbola because they're opening toward the positive y's and the negative y's. So now I'm ready to write my equation. It's going to be y squared, since it's vertical, over a squared, which is 9, minus x squared over b squared equals 1. I don't have to subtract or add anything in my numerator because I'm at 0, 0. These are the equations if it's not centered at 0. So we'll take a look at a problem like that. All right, find the coordinates of the vertices, the foci, and the equations of your asymptotes. Well, first off, it's going to be a horizontal because the x is first. My center is going to be at 0, 0 because there's nothing being added or subtracted in the top. The a value is first, so that's going to be 3. The b value is second, so that's going to be 2. So that means c is going to equal the square root of 13. Now it's just kind of a matter of plugging some stuff in, checking my formula sheet. So my vertices, since it's a horizontal, it's going to be 3, 0. and negative 3 comma 0. The foci is going to be negative root 13 comma 0, and then root 13 comma 0. And then your asymptotes, y equals plus or minus my b over my a x. Let's try one that's a little bit harder. For this problem, you will first have to complete the square. So take a minute and complete your square. Okay, it's at this point that I know it's going to be a hyperbola because of the subtraction, and also because I have coefficients in front of the x squared and y squared. So what I'm going to do is divide through by 36. So then I get x minus 4 squared over 9 minus y plus 1 squared over 4 is going to equal 1. So knowing that, then I know that my center is going to be at 4, negative 1. I know that my a is going to be 3. My b is going to be 2. So my c is going to be the square root of 13. Now I need to find the vertices and the foci. Now, I know that this hyperbola is horizontal because the x squared term is first. So basically, if I kind of want to sketch this out for myself, 4, negative 1, there's my center, right? Now, the hyperbola is going to look something like this and then something like that because it's a horizontal. So what I need to find is I need to find the distance from the center to the vertex. Okay, now I already know this. That's going to be a distance of a. Now, to figure out what that vertex is going to be, the y value does not change. Okay, so to figure out where the vertices are, if it's not centered at 0, 0, for a horizontal, it's going to be h plus or minus a comma k. And then my foci is going to be h plus or minus c comma k. Okay, and that's because it's a horizontal. So my vertices are going to be 4 plus 3, which is going to be 7 comma negative 1, and then 4 minus 3, which is going to be 1 negative 1. So we're going to say that that's over here at 7 and that's at 1. Okay, and then the foci is just going to be h plus or minus the square root of 13 comma negative 1. You don't have to simplify that anymore. You can just leave it alone. And then the equation for the asymptote is on your cheat sheet, so you just kind of want to plug it in. So it's going to be y plus 1 equals plus or minus 2 over 3 x minus 4. Don't worry about simplifying that because you won't be graphing that at all. All right? So then the last thing is just if it's a vertical and it's centered at h comma k, this time your vertices are going to be h comma k plus or minus a, and your foci will be h k plus or minus c.